Hello everyone, we've got our chapter 4 video. This is where we're going to talk about understanding and comparing distributions. So chapter 3 was all about displaying quantitative data, but we also wanted to be able to describe those distributions. So what we're going to focus on in this chapter is nothing new, except now we're going to look at not just one distribution, but we want to look at two of them at the same time and then compare what's the same, what's different about them. And in this chapter, I really want us to focus on being very descriptive when we describe a distribution. So up to this point, it's been kind of iffy, but really try to be intentional when you make your comparisons. And I'll show you plenty of examples here in a moment. When it comes to describing data, it's almost always more interesting to not look at just one group, but to compare what's happening between two different groups or three different groups, multiple groups. So here we can see we can do that with histograms. For each of these, we have summer and winter, and then we have the number of days where a certain wind speed was reached. So obviously, if you just look at the two graphs, they look very different. When we compare distributions, whether it's a histogram, box plot, any sort of graph, we want to address shape, outliers, center, and spread. Now, what we're going to see here in a moment is that simply saying, well, this is the center of summer, this is the center of winter, that's not going to cut it. We need to really use what's called comparative language. But right now, just take note of what differences and similarities you see between summer and winter. Now, just like with histograms, we can compare distributions using box plots or box and whisker plots. This is the exact same data that we had in the previous slide with the histograms, except now we've broken it down by month. So for example, if we wanted to compare January to July, these are wind speeds again, it's very clear that there are quite a few differences here. So the July box plot is much more condensed, whereas January is much more spread out. Also, if we're talking about the center or the median in this case, the median speed in January is at 2 miles per hour, whereas in July it's under 1 mile per hour. So just again, I want you to take a look at these, notice what similarities you see between the months and also what differences you see. So I think if I were today to give you an assessment and I said compare these two distributions, you likely would hit on a lot of the things that I'm looking for. But when I ask you to compare distributions from here on out, there are some very specific things that I'll be looking for. So I'm going to run through a few examples. But first, when comparing distributions, you have to address all of SOX and then put it into context as well. So shape, outlier, center, spread, and then put that into context. And really what we want to know is how do each of these differ? How are they the same? So do we have one outlier in one distribution and no outliers in the other? Is one distribution more spread out than the other? Are they centered at the same or a different value? And one thing we really want to be careful of is when we're comparing distributions, we want to compare the same measures. So for example, in one distribution, if we're talking about the center as a median, we want to compare that to the median of the other distribution. Same thing with IQR. If we talk about the IQR of one distribution, we don't want to talk about the range of the other one. We also want to talk about the IQR of that second one. And like I said, we want to put all of these descriptions into context. Everything in statistics has context, so don't just say numbers. Talk about pounds, talk about dollars, whatever your variable happens to be. And then finally, we want to use comparative language. So if you are in a foreign language, you probably talked about superlatives and comparatives. Maybe you do that in English as well. But we want to use words like larger or wider, more, less, words that compare one distribution to the other. So we're going to see a few examples here, and I think you're going to see it's really not too tricky. So here's our first example where we are comparing distributions. What we have is the scores on the Unit 1 test for Teacher A on the left and Teacher C on the right. So remember, when I ask you to compare distributions, we want to talk about shape. How are they the same? How are they different? We want to talk about outliers, center, spread, and then put it all into context. So that's what I have here, SOX plus context. I really want you guys to be expressive and use full sentences when you're comparing these. So my description here is both distributions are unimodal and neither have any apparent outlier scores. In that one sentence, I took care of three things. I talked about shape because I said they're both unimodal, and I also said neither of them have outliers. That's our O in SOX. And you'll see that I also put it into context because I talked about scores. So by saying both class distributions are unimodal and neither have apparent outlier scores, I've taken care of the 3 out of 5 of my things. Then I can go on to say the scores for teacher A are centered at 50%, which is higher than teacher C's center at 40%. So you see there, I used comparative language. Because there's a difference in our centers, I said that 50% for teacher A is centered higher than teacher C's center at 40%. And then finally, talking about spread, I said teacher A's scores have a much smaller spread than teacher C's score. And the reason I said that, if we look at our graph, the range is much smaller for teacher A than it is for teacher C. So what do we see here? In 3 sentences, I knocked out the whole comparison of these two distributions. I talked about shape, unimodal, they're both unimodal. I talked about how neither of them had outliers. I said that the center for teacher A is higher than that of teacher C, and also teacher A is much less spread out compared to teacher C. And then I talked about scores in there, so there's my context. So really do a good job of being very expressive in these types of problems. What we're going to see next is not how to compare histograms, but to talk about box plots. In this example, we have James and Angie, and our title is kind of off to the right here. It says miles run per week for the last 30 weeks. So what they did for each of these people, they logged how many miles they ran each week for the past 30 weeks, and the data is displayed here. So again, if we're talking about comparing distributions, we see some differences here between James and Angie. Obviously, they're not the same plot, so now we have to decide what's the same, what's different about them, and then put them into context. So let's talk about shape first. What I said is James' mileage distribution is skewed to the right. We see that tail is going off to the right, whereas Angie's mileage is skewed to the left because that's where her longer whisker is. So that takes care of shape and context. It says neither runner appears to have any outlier weeks for mileage. We don't see any points, so I've addressed that there are no outliers. Again, I talked about context too. Then if we're talking about center, I said James has a much lower median than Angie does, 5 miles versus 11 miles. So we can see that the middle of our box for James is 5, and for Angie it is 11 miles. And finally, for spread, Angie's IQR, that box portion of her graph, is much smaller than James's IQR. In other words, Angie's distribution is less spread out than James's. So you'll note here, you don't necessarily need to report or calculate different measures. You just simply need to compare them using comparative language. So for example, IQR, I didn't actually calculate what the IQR was for either of these. I just said Angie's IQR is smaller than that of James. I also could have done the same thing for median. I didn't have to mention the 5 miles or the 11 miles. I could have just said James has a 5 mile, or excuse me, James's median is much lower than that of Angie, and not mention 5 or 11 miles. So again, this does not need to be a paragraph long thing. You can make it probably 2 or 3 sentences and cover all the bases. Just make sure that you are comparing the shapes. Are they the same or different? Talk about outliers. Does one have an outlier and the other doesn't, or do neither of them have outliers? Talk about the center, compare the centers, and then finally talk about spread and then put it all into context. So you guys go ahead and try this one. How would you compare these two distributions? Take a moment, pause the video. We have young versus old people. What % of the time do you wear a mask in public? Okay, so if I had to compare these for shape, I would say the distribution of percentages for young people is unimodal, whereas the distribution for older people is bimodal. Would you agree with that? We have one mode for the young, two modes for the old. So that takes care of both the context and the shape. I would say that neither distribution has any outliers or apparent outliers that we're able to see. Both distributions are centered right around 50%. Young, that's where our mean would be, about 50%. And again, if we did the same thing for old people, mean would be right around 50%. One other option that you could do for center here is that instead of on the old distribution, talking about where the mean would be, talk about where the two peaks are. So we could say the young people are centered at 50%, whereas for old, we have a peak right around 0% and one right around 100%. And then finally for spread, because we aren't able to find IQR or standard deviation just looking at a histogram, I would say that the ranges are similar or the same, somewhere between 100% minus 0% is 100%. So again, I talked about shape, I talked about outliers, center, and spread, and I put it all into context. All right, so as you start to work on the homework, I want you to focus on these things. First off, make sure you're using comparative language. So words that end with ER, larger, smaller, wider, thinner, that kind of stuff. Also, like we saw in the examples, at some point you want to put everything into context in the problem. So talk about pounds if that's the units, or talk about dollars if that's the units. Also, you want to make sure that you want to address all parts of SOX, so shape, outlier, center, spread, even if there aren't any differences. So if the spread is the same for the two, just acknowledge that the spread is the same. Also, don't separate your comparisons into separate sentences. I would say compare them within the sentences. So for example, don't just say the median of this one is 50. Then in another sentence, the median of this one is 40. You want to use that comparative language saying the median of the first distribution is at 50, which is greater than the center of the other distribution, which is 40. So again, using that comparative language, putting that all into one sentence. And finally, just as a tip to you, you don't necessarily need to report the calculation for center or spread, but if it's given to you, that's just going to make describing things easier. So if you just notice that one distribution is more spread out than the other, you can just make a note of that. The spread is greater than the other one. But if I give you the IQR for each distribution, then you might as well reference those. So as you work on the homework, what I would encourage you to do is not only try these on your own, but reference back to my answer key, which is on Google Classroom. Make sure that you're being descriptive enough. This is something we really want to develop a good skill of doing, especially as we get closer to the test and ultimately to the AP exam.